Hi, I'm Glenn Heemstra from Futurist.com, and I'm on the organizing committee for the Future in Review conference, which happens each year, sponsored by Mark Anderson. This year, the 2010 conference, as before, has selected a number of early stage or startup companies to be FiReStarters, and these are companies selected primarily on the criteria that they have a significant chance of making a big difference in the world, as well as a chance of being successful as a business. And today I'm talking with Matthew Klipstein of Neuro Repair, who has quite an amazing breakthrough in medical technology. And it has to do with brain injury and the long-held belief that once you have a brain injury, there is virtually nothing that can be done about it. So Matthew, tell me about Neuro Repair and the discovery that you've made.
Well, Glenn, my founding of Neuro Repair was what you might call reluctant. It was not something that I had intended to do. In fact, I knew nothing about this area of inquiry at all until I suffered a neurological injury. And I had one doctor after another tell me that my situation was absolutely hopeless. And as you've mentioned, that what has been long-held medical doctrine, bedrock doctrine, virtually forever, that once you have a brain injury, that's it. There's nothing to be done about it, that the brain has no mechanism for repairing itself, and that there's no treatment.
Well, you know, we have in our family a good friend who suffered a stroke maybe 4 weeks ago, and it's a significant stroke, and so now she's in, you know, very intensive physical therapy on the idea that there will be some limited amount of reconnections, new connections made in the brain, or retraining of the brain, and that's about as far as it's ever been able to go historically, right?
That's right. There is the theory of neuroplasticity, which frankly works a lot better if you're 6 years old.
Yes, yeah, she's 69, and so it's a different story.
There's never been any thought that the actual injury could be repaired, or that new neurons could be formed, or new connections made. The best any doctor has ever offered as hope to any patient, I believe, is that your brain can be retrained to circumvent the broken circuits, essentially.
Yeah.
To go around the damage and perhaps perform some of the same functions, but not as well.
But somehow you came upon a methodology, chemical methodology basically, I think, to in fact regenerate neurons.
Well, I wouldn't take credit for any of the science. In fact, it's sort of a mystery how someone like me could make it through 4 years of high school and 4 years of university without ever taking a science class. No one knows less than I. What I did was, when I got out of the hospital, I started to do research once I could read again, which was probably 5 or 6 months. And there was no Google then, but there was Yahoo, I believe, and Alta Vista. So there were search engines. Mm-hmm. And I started to do research on who was doing something of interest in the area of neurological repair. And as you might imagine, there was almost no one. That stands to reason. If everyone is taught in school that it's impossible, can't be done, then why bother trying? So virtually no one was doing anything, and I found perhaps 3 or 4 different research hospitals that were working on it a little bit. And then I discovered Dr. James Fallon, who was at the University of California, Irvine School of Medicine. And Jim seemed to have the most advanced research, and he was geographically convenient to me because I was in San Diego. So I contacted him, and then we just started to talk. At the time, I didn't understand that Jim got calls like mine from distraught patients all the time. What are you doing? Do you have any clinical trials? Can I get into your clinical trial? Because the fact is that anyone with a brain injury is absolutely desperate. So they'll try anything. So I did meet Jim, and he was kind enough to meet with me. In part, I'd have to say, because I said, and this was true, I had been lucky enough, I suppose, to have just sold a company perhaps a month and a half before I got hurt. So I had some money.
Mm-hmm.
And I just volunteered that I had money to support his research. Because sadly, in the wealthiest country in the world, we have virtually no system of reliably funding this kind of research. It's all done in kind of a patchwork manner by corporations or individuals or foundations. In fact, if you're a university professor working on something, the university will just tell you, go out and find a corporation to support your work, mm-hmm. because we're mm-hmm. not going to do it. Mm-hmm. And so that's what I did. I became a sponsor of Dr. Fallon's lab. And in fact, the university refused to deal with me as an individual. This is sort of silly, it seems to me. But they insisted that I form a corporation. And that was the genesis of Neuro Repair.
So that's the beginning of Neuro Repair, and then the discovery of Neuro Repair has to do with a naturally occurring, is it a protein or an enzyme or that?
It's a naturally occurring protein,
okay.
Biologically active protein called a cytokine. And the subset of the cytokines is a group of proteins called growth factors. The one that we use in particular is called transforming growth factor alpha. Rolls trippingly off the tongue, one might say.
Well, it's not bad. It's not bad.
It's why I believe scientists should not be allowed to name things. It's a terrible name. Because transforming growth factor alpha sounds like something that causes cancer or does some other terrible transforming thing.
Actually, it sounds like a term from a science fiction novel to me. But so this transforming growth factor alpha is obtained, refined. What do you do with it? How do you get it to the brain?
Well, that's actually an interesting subset of the story, because method of administration is an important issue. The brain, of course, is designed so that you can't get things into it. It's, of course, covered by this thick skull, and that's meant so that you can't get into it. And the brain, of course, also has what's called the blood-brain barrier, mm-hmm. which are capillaries that are different from other capillaries in the body in that they are composed of thicker cells, more tightly woven, so that only very small molecules or molecules of a very specific geometry can get through the walls of the capillaries into the cells. Mm-hmm. Mm-hmm. So that sugars can get through in order to nourish the cells, mm-hmm. but very little else. And that's intentional, if one considers that nature has an intention, in order to prevent, for instance, bacteria from getting into the brain. Because the brain has virtually no immune system. So once a bacteria is in there, you're in serious trouble.
Yeah. So the methodology that you came up with has to do with...
Okay, well, essentially, I came up with nothing. Jim was the first person ever to localize, which is to say find, TGFA in the brain. TGFA was already a known molecule.
Okay.
But he was the first ever to find it in the brain.
So that it pre-exists in the brain. It's part of what is in the brain.
Yes.
Okay.
Mm-hmm. Mm-hmm. It's a bit of a mystery to me that evolution or God, take your pick, whichever, would design a system for repairing neurological damage that has the capability of working beautifully, of repairing extremely intricate and subtle damage in this enormously complex organism we call the brain. And it is astonishingly complex.
So what transforming growth factor alpha does is trigger the creation of stem cells in the brain, which then stimulates growth. But
precisely.
But just does it a tiny little bit when there's an injury, not enough to make any difference?
Well, exactly. That was the point I was starting to make, is that the system exists and it has the ability to work beautifully, but in nature it doesn't work at all. Because if you sustain an injury, your brain will secrete a very small amount of TGF-A, which will stimulate the proliferation of a very small number of stem cells, perhaps 20 or 25 cells, which is therapeutically useless. However, if we boost it, if we sort of give it a kick in the butt, by injecting more TGF-A, we can find a proliferation of 20 or 30,000 cells, and that is therapeutically efficacious.
And so how do you inject the TGF-A to the brain?
Well, in lab rats, of course, the way that it's done and the way that generally would be proposed to do with a patient like me is to drill a small hole in the skull, and most neurosurgeons will tell you, well, that's no big deal. It's just a hole in your skull. We just use a drill. And then they thread a needle called a cannula into your brain. And in this particular instance, they would attach that cannula to an osmotic emitting pump and leave it there for a month. Now, I don't know what your thought about this is, but to me, the idea of walking around for a month with a needle in my brain is a little creepy.
Yeah.
So I would say that if I added anything to the mix here, other than writing checks, which has basically been my function, Jim does the science, I write the checks. I was the one who insisted upon finding a more acceptable method of administration.
Right.
And what we discovered was that it had already been found by someone else, a neuroscientist by the name of William FiRe. Bill discovered that you can literally snort a fluid back into your sinuses, and if you get it into exactly the right part of your sinuses, which is something of a trick because it's quite a maze back there, you can get droplets of this fluid to collect on the olfactory nerve and another nerve called the trigeminal nerve bundle, both of which run from the back of the sinuses to the brainstem. And these droplets will physically drip their way back to the brain, which is quite remarkable, it seems to me. It also seems odd to me that nature would go to all the trouble to create this very elaborate blood-brain barrier and then give you a trap door, a way around it.
Yeah. Well, it's almost as though, that's an interesting thing. So there's a trap door to the brain, and you've been able, I know, to do these experiments with rats at this point, which have been quite successful.
They have been stunningly successful. As we talked about before, I'm wary of overstating or sounding like this is puffery or that I'm trying to sell anything. I'm not trying to sell anything. But the fact of the matter is that when we published our papers demonstrating exactly what we had done, what our experiments were, and by the way, these are experiments that have been conducted by very smart people at a very reputable research hospital at the University of California. So this is not junk science. The response we got worldwide was overwhelming. This is stunning stuff. This is really startling.
Yeah, it's rare that such a long-held paradigm, belief, article of faith is potentially completely overturned, 180 degrees.
Exactly.
Yeah. This is, it's just huge. Now, anybody who happens to watch this video and knows of or has their own brain injuries is going to ask two big questions. I think. One is,
how can I get it?
Yeah. How can I? When might this you know, be accessible, and that there's no way yet, I don't think, for you to answer that. Another question that I have, though, related to that is there an age, just as if you suffer a brain injury when you're 6 years old, the plasticity of the brain means you're going to recover more than when you're 60. In this one, is there any age difference, or if you've had a brain injury years ago, would the treatment, you think, be effective?
Well, actually, two different questions.
Yeah.
I think I can answer both.
Yeah.
There seems to be no difference respecting the age of the subject. Although the long-held doctrine has been that there are no stem cells in the brain at all. There are, and they seem to persist throughout your life. So at 70, you still have them. And they're still available to repair damage. As far as your other question about the age of the damage,
yeah,
that's a big deal.
Yeah.
And I would say that's probably the most exciting thing that we've discovered, except perhaps for the initial discovery that neurogenesis is possible at all, which, as we've discussed, has long been held not to be possible. We have found that we can, in fact, treat what I call old injury, what a doctor would call a chronic injury. But,
excuse me. Oh, I don't know if that's mine. It's not mine.
oh, I'm sorry.
That's all right. Just let it ring. It's the age-old thing, and we'll edit. That'll be edited out anyway.
Okay.
Yeah, yeah. So once the ringing stops, then we go ahead. So the age-old belief is that a chronic injury is probably going to be less treatable, and you have news that it may not be true.
Of course, the belief has always been that no injury was treatable. I mentioned before that there were a very small number of scientists around the world who were working on this issue, even though they'd all been taught that they shouldn't bother because it's not possible. Of all of them, I would say only one was willing to even try treating an old injury, and that was Jim Fallon, and he did that very reluctantly. He did it because I absolutely insisted, and I insisted not because I know anything, but because I don't know anything. I didn't know enough to know that that was almost certainly impossible. Jim was very reluctant, and that gave me some indication that even he believed it was not possible. I insisted because over time my injury, of course, had become an old injury. And by old I mean fully stabilized, so that you're not observing any evolution in the damage at all. So that it appears to be completely static.
Right.
But the answer is yes, we can treat that, and it does work, and it works stunningly well. It's almost completely efficacious. We have almost 100% functional recovery.
This is incredible. It really is amazing. So take us ahead. I know it's been a very long struggle. It's been taking much longer than you imagined that I would, but for my own interest and for the people watching this, you know, where might we be a year, 2, 5 years from now if everything worked in a way, I suppose, more optimistically than it did starting for you 10 years ago?
Well, I've told you the exciting news, which is first that brain injury can be treated, and secondly that old injury can be treated,
right.
And thirdly that there is a very efficacious but completely non-invasive way of administering the protein that we need to get into the brain. The caveat to all of this is, in fairness, our research, although it has been startling in its results and really, really very exciting, it's preliminary. We've done rats. At the University of California, I'm not sure it's possible to do monkeys. I don't think any campus does monkeys. And it's very difficult to go from rats to humans. The typical progression is everyone begins medical research with rats, then you go to some other mammal, hopefully primates, and then humans. We believe, and we think we're on the verge of skipping the primate stage entirely and going directly to humans, because after all, TGFA is a naturally occurring protein, and it's in your brain anyway. and we know that it can't hurt you, which of course is the great concern.
That helps, yeah, yeah.
So as I started to say, the caveat to everything that I've said so far is that our research is, I would have to say, preliminary. We've done rats, we've had great success, but however, and this is the caveat, it always starts with but however, if it should eventuate that, notwithstanding our tremendous success in rats, this doesn't work in people at all, it wouldn't be the first time. It would be tremendously disappointing, and every indication is that's not going to happen. But it could. And it has happened before that things have worked in rats and then not in people, and no one knows why. So that's certainly another hurdle to be overcome. We haven't gone all the way yet.
Yeah, but you're in the process of beginning to approach that hurdle, and so we might know sometime relatively soon, by relatively soon, in years, not in multiples of years.
Actually, we're thinking 1 year we'll know.
Really? Okay. Yeah.
What I expect is that a year from now, I'll see you again at FiRe, and I won't have the cane, I won't have the limp, I'll have a left hand that's fully functional, and I'll have my world-renowned cognitive abilities fully restored. Now, do I know that will happen? I don't, of course. No one knows. It may or may not. So you're wondering, what can I tell you for sure? And what I can tell you for sure is, I know that it's possible. And a year ago, I knew it wasn't. And I think that's important.
It's incredibly important. It's such a great story, and we're all going to watch for progress with Neuro Repair. It's Matthew Klipstein. Thank you very much. Congratulations on being a FiReStarter. We will be back here next year at FiRe. We will see you, and we'll hope that the progress has been as you envision it to be. Thank you, and good luck.
Well, I'll certainly do my best, and thank you for the opportunity.
You're welcome. Thank you.